Now, we know VE is 50 milliliter. Now, the other two conditions, the 10 milliliter is smaller than, sorry, it's smaller than 50 milliliter, right? So this is before. And the 52 is larger than VE, meaning that it's after the equivalence point. Okay, let's deal with the 10 milliliter first. How would you calculate the concentration of silver before equivalence point? If we quickly go back to the instruction, in this case, you have excess amount of analyte. So you have to calculate the concentration of analyte first, which is the fraction remaining multiplied by original concentration of ionite and multiplied by the dilution factor. Okay. So what is the fraction of remaining here? As we said that the denominator should be the volume, the total volume you will be needed, which is the VE, right? And then the fraction remaining is VE subtract the add amount. Yes.
40
so
over
this,
50.
Yeah, so this is 50 subtracted by 10 divided by 50. Okay, now the original concentration of iodide is 0.100, no question. What is the dilution factor?
The original volume over original volume plus added volume.
The original volume is which one? Which number?
The 10 milliliters?
10? Well, why is 10? Yeah, it's the original volume of your solution, of the solution in the LML flask, which is the 25 milliliter of sodium iodide. The 10 milliliter is what you added to the solution. Okay, so this is 20 and 20 plus 10. Okay, so this is the original concentration. This is the V add, V0. So these two together is the final volume. Okay, so by doing all this, what do you get here?
.0571.
And how many sig fic?
3.
3. Okay. 0.0571 sub 4. Okay, so this is our iodide, but what we're looking for is silver, right? How do you get silver?
ASP divided by 0.0571.
Yes. So by using the solubility product, which is 8.3 times 10 to the negative 17 divided by So let's not run too early here, okay? Because we still have one more step to do. So let's keep a sub number here, 1.45. And then you do the PHG, which is negative logarithm of 1.45 times 10 to the negative 15. When you're looking at this number, you know that this number should be 14 point something, okay? If you don't get 14 point something, it means something is wrong with your calculation because we have negative 15 here, right? Again, it's a logarithm case, and we have 2 sig fig in the original number. It means that after logarithm, the mantissa part should have same digits with the original number, meaning which is 4. So we have 14.84. Okay. So that's the before equivalence point. Now, the last one, 50 milliliter. This is larger than VE, which is 50 milliliter. So this is after. And for after, we will have excess amount of silver. So we directly calculate the excess amount of silver ion, which is silver ion concentration will be the concentration of silver, which is 0.05. And then the top is the volume in excess, right? You only need 50, but you added 52. So the volume in excess is 2 milliliter. And then the bottom is the final total volume for counting the dilution part. The dilution part originally, so the denominator part is always the total volume after adding the titrant. Again, because initially you have 15, and then you added 52. Originally you have 25, so 25 plus 52. Okay, now what do we get here? Well, we need 2 sig fig, right? So it's 0.0013 sub 0. Yes. And then PAG will just be negative logarithm of 0.00130. And what do we get?
Would it be wrong if I put 0.0012 sub 9?
Yeah, because after 9, you have a number larger than 5, right?
Yeah. Okay.
It doesn't affect your result that much, but if you want to be accurate, when you run the number, it should be 130 instead of 129. We got 2.89, right? Again, it's a logarithm and we have 2 sig fig here. So the decimal place should have 2 digits, 2.89. Okay, so if we write all the all the PAG together, still remember at the equivalence point, we have 8.04. So starting from 10 milliliter to 50 milliliter, which is the VE. VE is about 8 the PAG is about 8. And then before VE, you can see that the PAG number is relatively large, meaning that your concentration of PAG is actually, the concentration of silver is actually very low, right? When you have a larger pH number, it's a lower concentration. And after the equivalence point, you can see that the PAG value drop a little bit. So the concentration of silver actually increased pretty fast because there's no iodide in the solution and you just keep adding silver to the solution. So the concentration will be accumulated very fast, okay? Excuse me. So as I said, I have to be the host of today's seminar. So we're going to finish today's lecture early. I'm going to stop here. So unfortunately, we didn't have time to start the activity part. We will start that part on Thursday, okay? And thank you, everyone. And I will be seeing you guys on Thursday.
Thank you, Professor.
You're
Thank you,
welcome.
Professor.
Professor.
Thank you, Professor.
You're welcome.